All right, YouTube, it seems we're live. Let's see. Very good, we're live. Turn off this one. It's the control room, it's fine. I don't need it. I don't need you. All right, welcome everybody. We're live again. It's almost 10 a.m. Central European time for another time for another live coding session. We're building a trivia game in Clojure and ClojureScript. Let's first start with some questions and answers. I had a comment from Herb Martin. It's funny because there's Martin Clausen last time. Herb Martin. There's something with the name Martin, I guess. Said, excellent series, please bump the font size for the following ones. Good feedback, so I did. Herb, I hope you like it. It's now at 16 points, I think, 18, something. Let me know if you like it, or if it should be even more. My cat. Ink. Yeah, I cool it. I'm gonna let my cat out real quick. One moment. Cats, they're master manipulators. All right, so where were we? I bumped up the font for her. I hope you like it. Let me know if it's better. The focus for today is to create an API in Clojure. We already built something really nice. If you remember, our application is quite complete already on the front end side. You can log in. You can create a game. I added some more questions. I actually found some questions from Who Wants to Be a Millionaire, the $1 million question. So if you can answer them, it's very good, right? So there's not a lot. I think I added 7 or so, but it gives some more feeling to it. So I know it's 93 million because science for the win. Seto, I believe. It's awesome. It is very awesome. There's still too few questions to be truly random. So maybe we should figure out a mechanism for this. But that's typically something that we can fix on the backend side. So all this does for now is loading a reframe application, and it's using its own db.clojurescript for the questions, right? So all the questions are loaded from its own database, and in the event handler, event ClojureScript, we have the next question event that actually takes a random question from the database, which is not very good at the moment, but it's also localized. So what we want to actually refactor this next question to talk to a backend service that gives us some form of question. Let's first start off by just trying to replicate this behavior, having a map with an ID, the question, and a list of answers. But what we can do is create 2 endpoints, one to get a random question and one to submit a given answer and get a result of true or false. The submit answer, we created an effects handler for submit answer. It takes the cofacts and it basically looks through the answer that was, it looks up the question, then looks up the answer given, and then checks to see if the answer given was correct. So we could refactor this to be a result, and to first do a HTTP call to the backend saying, hey, I have an answer. And then using the result, it would update the interface saying, hey, the question was answered correctly or not. So that's all fine and dandy, but how do we do that? And traditionally there's two ways to create. There's many ways to create APIs, but there's two ways that I like. And the first is just a simple REST API. It's HTTP protocol that says it uses the HTTP protocol, I should say, and you just create endpoints and you say, well, do a get on /question, and you will get a random question. Do a post to answer with a reference to, do a post to the question, do the post to the answer and say, I have an answer for question 5, and the answer given was 3. And it would say true or false. So what do we need for that? We need some form of web server to do this, of course. And we need a database, and we need the API itself. The second way of doing it is using the same things, really, the web server, database, and the API, is by using WebSockets, and that means that you create a persistent connection between your browser and your web server, and you basically push messages back and forth. That has the benefit that if you do a multiplayer game, for instance, you can asynchronously push messages to your front end to say, hey, my buddy answered the question correctly and he's ahead of you now, for instance. It's a little bit more advanced, but once we add multiplayer capabilities to the game, we should actually use that. But for now, I think the easiest way to get into it is to create a REST API. We're gonna make it in a way that we have the ability to change the way we communicate with each other. So if you look at how you build a system, you could just instantiate a web server and then push an API onto it and then have it hard-coded talk to a database. But that's not the way you want to build your application, not unless you want to use it for a little while at least. And what you want is to create a system that has different components that you can actually turn on and off or change around. For instance, talk to a database, or just use a memory storage, or use HTTP REST for API, or use WebSockets for API without changing all the other parts of the system. It's quite difficult to make a good system like that, and luckily within the Clojure community there's a lot of very smart people who have thought about this. One of those very smart people is Stuart Sierra. He created a library called Component. It's located here. I will post a link. Let's see, where's the video? I will post a link somewhere below there and when I'm finished. Component allows you to create software where all the functionality is within a single component. So your web server functionality is within the web server component. Your API you get through a dependency maybe, or the database you get through a dependency, which means that if you want to change web server, or if you want to use some radical new technology to expose your API, you can just switch them around and add the API and database as dependency to the new component without having to rebuild everything. To me, that's very good design. But it takes a little bit of work to get everything running because it's not easy building good systems. It's very easy to just build something, but building a system in a way that you can use it for many years without having to rebuild everything every once in a while, that's quite hard. So let's try and use some good design patterns for this really. Stuart Sierra not only created a very good library called Component, he also made a workflow of sorts that he calls the Reloaded workflow. And that basically allows you to um, um, init, reset your entire application from within your current live REPL session. So you don't need to shut down your REPL and then have to start it again to have changes to code be effectuated. Um, so we're going to use that. He actually has a linear template from which we can just steal everything. So we don't need to, it's kind of boilerplate if you will. So what else are we going to use today? I figured we should use compojure-api. Composure itself is the routing framework on which you can create web server applications. It adheres to the HTTP standard, so it has get, post, put, delete, patch, what else? Head options. And Metosin, he created compojure-api, which combines the Composure library with prismatic schema to validate input and output. It uses Swagger, which is a really cool library that creates documentation and a testable platform for your API. And he did a lot of other cool things with it. So let's use that. And prismatic schema, of course. And for our web server, we will use HTTPKit. It's one of those. It's one of the many different possible web servers that you can use. Why this one? Because it also allows us to later on switch around from having the Composure HTTP library as an API to going into a WebSocket API. And perhaps we can even combine the both, right? That would still be even more awesome and would show the power of the component library, which is a good idea. So let's just do that. So to get started, let's first implement our reloaded workflow, which is not a lot, right? It has a init, start, stop, go, and reset. And we will just do this, copy and paste, because why not? Stuart Sierra says, well, you should actually put this in a separate space. It's called a dev closure, which will only be utilized when you're in development mode. And this should fail miserably, by the way, because we don't have refresh. Where's the REPL? Let's put a REPL on the bottom. If we evaluate this, it says refresh is not available in this context. But that's because refresh is actually something from the Closure Tools namespace REPL. And if we look at his project, it actually has the org Closure Tools namespace and then a particular version. He puts it in the dev part. I'm not going to do that right now. It's something to refactor later on. But I don't want to make it overly complex at the moment, so we will just add the dependency. Org Closure Tools namespace. And he has 0 to 11, 0.2. Well, 11 seems to be the latest. So we will add it. It was added to our running REPL. This is one of the benefits of using CIDR within Emacs. Yeah, it's awesome. Everybody should use it. I understand not everybody wants to use Emacs for some reason, but Right? So we're gonna add, as we said, the namespace here. So we will just do that. Add a require closure tools namespace, right? As namespace, well, we don't need it. We can refer refresh, right? And that should make everybody happy. Refresh does not exist. Why does refresh refer? Oh, toolspace namespace REPL, right? There we go. So we evaluate everything, it should be fine now. So now we have a system that can go. We have a init function, we have start function. They don't do nothing yet, but if we go and say go, it should say ready. If we do a reset, after should be a namespace qualified symbol. That's interesting. What does it say? Refresh after go. Go. Should it actually be in one of those? Serious? Thought it was a copy and paste thingy. Oh, alright, I was wrong. So we now what you see when you do the refresh with the reset, if you do a reset, it will refresh all the namespace. So if you created some extra symbols within your namespace, it will actually clean those out. And in this case, it reloaded pretty much everything that was inside the namespace. And so you're left with a clean namespace, which is very good. So now we have a very good init function. We can get rid of this one. And these are the questions that I took from the internet. It's called who wants to be a millionaire from the US Game Shows Wiki. Thanks for that. That was very good. Reloaded, we covered. So now we're gonna start up building our system. And the system contains components, and components do stuff, right? So if you think about that model, you have something that kicks off a system, you have a description of the system, and you have the description of each individual component. So let's create a well, let's start with the HTTP component, right? Where are you? HTTP kit. So we add HTTP kit. There you are. And the most recent version is 2.1.18. We add, beautiful. We add HTTP kit, and if you look at the documentation for HTTP kit, it's not very clear at the moment. But there's this section called restart server, and what it does, it tells you that when you want to stop a server, you should actually take the thing that was returned by the function called run server, give it a timeout, and that will stop the server. So what that tells us is that we need a mechanism that says we're gonna start a web server, we're gonna stop it, and we're gonna save the thing that was returned by run server during the lifetime and just deal with it. This is exactly what component does. Component has a mechanism that says we're going to start a component, we're going to stop a component. And in the effect, you have a restart then, because stop and start is a restart. So, and this is exactly where Stuart Sierra's beautiful library comes in. So let's create a web server closure. And we will basically create our first component. And if we look at the documentation for it, documentation, there we go, blah, 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 blah. And the entire setup for component is based on a protocol called lifecycle that implements the start and the stop function. Very important part of component is that when you do a call a function of a component, it should always return an updated version of the component. That's totally in line with the functional pure nature of the closure system, of course. So let's def record web server. Let's create our first component. We said it should deal with a HTTP server, so we will have a server parameter that will hold our web server component. Component. Oh, we did not even include component yet, so right. We skipped over that part, so let's add it. Let's do it. You should always take care of this and to take a look at the actual name of a component, because there, for some reason, many libraries are available with various names. I think people made boo-boos, and sometimes it does not get cleaned up. Maybe because of dependencies from other libraries, might become a problem in the future. But for now, it will be fine. You should just be very aware of what libraries you're including. So we added the library to our system. Now let's do the component slash lifecycle. Would be component start so your component lifecycle implement steps. Yes, implement steps. I always forget the key binding for them. Refactoring that implements the stops. It seems like nothing, but it's good to have the key bindings in your head so you can work quite fast. But now I'm just trying to implement the stops and I flake out. Thread last, cycle, introduce let. No, that's not what I want. Namespace project refactory. No. Last try, top level. Add stops for the interface protocol. Add stops. There we go. It's not implement stops, it's called add stops. So. There we go. So we added the stops. Let's make first rename symbol. Yes, this should be components. Components. There we go. So when the component comes to life, it will have this server parameter will be part of the component itself. It's basically a big hash map which has data in it. We can actually see this by doing a def new web server. We don't need parameters, and we can call map web server. There's no parameters to give. So if you evaluate this, it creates a record of the web server. The life cycle you can see basically as an interface. It tells you what what methods or functions are available for a given record. And so when we create a new web server, we get dev web server, and we will call new web server. So if we evaluate this, you can see that the web server, the record, actually the instantiation of it resulted in a trivia web server object, which has a hash map in which server currently is set to nil, which is exactly what we expect, right? We expected that this would not do much, but now you could actually call start on this object, and currently it will do nothing. And if we say we would like to stop as well, and if we add some prints to this, print start, stop, we evaluate it, we re-instantiate it, and then we go to start. You see in the REPL that it actually started the application, and when you call stop, it actually stops it. And this server parameter is still it's being carried through its life cycle. So what the documentation for the HTTP kit said, that if you use it, you need to create an atom to hold the web server. Well, we're not going to do that. We're adding it to our web server object. And then when you want to stop it, if it's not nil, then you can just call it and with a timeout, and you reset the value for server to nil. And when you want to start it, you call run server. You have an app, something that will give an answer, which would be our API really. There's options map called for port, and that should be it. We save the value. So if we just add a HTTP kit, what would the namespace be? Org HTTP kit. It's not very consistent because the package name is called HTTP kit. So you would expect the package name within Clojure to also be HTTP kit, right? So if we're going to start it, we need a handler. So we will just take this example for now, so that we have something that we can add to it. And then we can basically just take this example here and say run server app on port 8080 is fine by me. But we need to save the server somewhere. So since the component is a map, we can associate component server to be the result of run server. And as the result of the start function is the component itself, it should be part of the web server itself, the record web server. So when we want to stop it, the check here when not nil is of course meant to prevent null pointer exceptions. You have them in Clojure as well, as it's part of the JVM, and it also allows for idempotency. Fancy word to say that you can call the same function over and over again with the same result. So let's just take when not nil. So what should be nil? Let's or it should not be null. That would be the surf. I wonder if we can just do this. We can fail miserably if we want. Okay. Important to note here is that, well, it's an atom, so it should not count. Why not? I think we're gonna fail miserably now. Timeout 100, and the result should be an assoc where components server is nil. Right. Run server is undefined because that's part of server. Yeah, this is not very. It's going to be a problem. Let's call this HTTP because we have a server variable, we have a server namespace. It's bound to be troublesome. This is all evaluated. This should work nicely too now. Let's evaluate everything, right? So if we look at web server now, it's still that object which has nil as a server value. When we start it, you see that server actually changed to a function instead of the value nil. And the web server here is nil because this is not the same object. So we should save this object because when we now do stop, it does not do anything. And we messed ourselves up right now. If we go to localhost 8080, it says hello HTTP, and we have no way of stopping this, right? We shot ourselves in the foot, or I shot myself in the foot. The object that holds the function reference, or the map that holds the function reference, is now somewhere. I did not catch it here, so we cannot stop it. Normally you create a system that holds the components. I want to show it, and I failed miserably, so I need to kill all the REPLs and then start them again. Time for some coffee, this time not being cold. Well, almost. Well, we should see that localhost 8080 is now not functioning. So let's start creating a system already, because then we can just stop it. Oh. And the documentation for component also has this really nice part about the systems. A system is really nice. It allows you to map out the dependencies between the components and just say, I have a system map which consists of a database, a scheduler, an application itself, but the application depends on is a component using an example component with config options. You can also, so the application is actually a component that depends on other components. The component for the application itself is the example component, and it depends on a database known as DB here, a scheduler known as scheduler here. The more shorthand syntax for this would be to say component using. So example component is dependent on the named entity database and the named entity scheduler, which are both in the system app. So we'll use this syntax because I like it better. Let's see if everything is running. Yeah, so we're back, right? Let's not do that again because it just wastes time. So we created a system, and a system is nothing more than a function returning a system map which can be started and stopped. Right, so let's defen system. Will not pass any parameters at this moment. There's no options that we need to take care of at the moment. So for why not? We can do config options. We can make the port configurable, because then we have the infrastructure in place and we know how to do all these things. Keys, port, of config options, and what it does is component slash. And this is the really nice thing about Cider. See how it automatically expanded this known namespace. I love Cider. System map, and we only have an HTTP connector at the moment, which is actually part of a web server. Does not do it for everything. So trivia, web server, web server's new web server, and we will pass the config options. Web server does not support that yet, so we just config options. We will pass it here. Is that relevant at the moment? Port, well, we passed an entire config options part, right? So that should be fine. Then we can just say port, it is a known key, so it's a known key in the map, so as long as we add the key port to the config options when we create the web server, it should be fine. It's all fine. So we should have a system now. It should evaluate, it should work, and the system becomes something that we want to cherish, right? We define it once, and then we can call start and stop on it. As you can see, in the example here, entry points for development, it says you define a variable called system and you add your system to it. And then we have the alter var root, which starts and stops that system variable. So the alter var root is one of those things that is quite, it has a side effect. It changes system to be the result of the component start, and etc. etc. So where should we put this? We should put this in our start and stop part in our reloaded workflow. So if you go to core trivia, let's for now just say system would be, and let's add a dependency on trivia dot system. It's called sys system slash system, and we will do a port of 8080. So this is our config map. So we will basically be calling this function with a variable called config options, which in essence is a map, which says port is 8080. We could, if we wanted, pass more options along at the moment, but there's no need for it. So if we evaluate this, you will see that sys is a system map, and that system map will know about our components. So what we do now in it, we don't need to do anything. Start, we do an alter var root of sys, and we're going to call the component slash, and we'll evaluate it there, start function take this and the stop. So this should mean that if we put a REPL here, we can go back to our failed localhost. It's still there. And we say go. It says ready. It should have hello HTTP. And we could say stop. It returns the component itself, and the component now has the result of the HTTP component on port 8080 with the server nil, which should mean that we have nothing here. So we now created a start and stoppable component that has an HTTP server. For now, let's just keep it running. There we go. So this web server, REPL, web server. This web server, it is very good. We created hello HTTP world. Would it reload? That does not reload, right? So this is where the reloaded workflow comes in. We made a change. Oh, there we go. We made a change, and because this is passed in as a reference to this function will be called every single time. We can compile it or evaluate it, and it changes. Once you no longer have that ability for some deeply nested APIs, for instance, then the reloaded workflow is quite necessary, because it will reload the entire namespace, and your change would be there. So we have something that we can start and stop. We're done with Stuart Sierra for now. We're done with HTTP. Now we're gonna need a web service, right? We want the API. So let's add in compojure-api from methosin compojure-api and 118. There we go. It should load. Bam, it loads. And what we also need is schema, the prismatic schema. That's not what I wanted. Prismatic schema. Currently there's within the Clojure community, there's the spec, clojure.spec change coming in the 1.9 version of Clojure, which will probably make schema obsolete. For now, the compojure-api works with it, with schema, so we'll use it, but once the Clojure spec is fully available and integrated in the various libraries, we should probably change to that. So we're gonna make an API, and if you look at what is required to make an API, it is quite easy, really. You just call dev API, and you create an app, which is the same thing we created here. So maybe we can just change it. Let's give it a try. So we need a require on compojure.api.suite. Suites, right? And he says refer all. It allows for dev API to be used, etc. And we need something for the HTTP response. We need that from the ring library. I don't know if we already have ring.util response. Maybe it came in with a dependency. HTTP response. It's the thing that will allow us to say Yeah, okay. Do a HTTP 200 as a result, or give a HTTP 401 without having to know what that means. So def API app. Let's just take his example here to make sure that everything is working. There we go. And now I'm wondering if this immediately stopped working. Yeah, that's quite nice. Hello? Hello, missing required key. Here we already see something very nice of the Composure library and Composure API, is that we told it we're expecting a get on the endpoint hello, which is quite easily here. And what we expect is that within the query parameters, there's a parameter called name of type string. And when that all matches, we will return OK with the message saying string combined of hello and name. So if we do hello, name is Aryan, we say hello Aryan. So we already have an actual working API. If you hear a lot of beeping, there's a lot of construction going on outside, so it is quite annoying every once in a while. But what we want really is to have a fully documented testable API. Swagger provides that. So how do we get Swagger to work correctly with the API? Well, we need a little bit of change. Throw that away, def app becomes API. So we step away from the dev API and we pass along more parameters. So the Swagger takes a map saying the UI is at /API docs. That's fine. The spec will be saved in swagger.json. The library generates a JSON object that describes the API. And the library takes care of that for us, so we don't need to worry about it. Let's add some info, title, and we call it Trivia API. Description, why not be specific? API for our trivia game. There we go. We can create some tags, and tags are used to basically to put endpoints into compartments, in descriptive compartments. So we have tags. We have currently only a tag called questions, because we're retrieving a random question, submitting an answer. Maybe we will add friends to it, so we can have functions grouped. It's a grouping mechanism. That's what it is. So we have functions grouped in logical domains. Descriptions. Functions dealing with questions. Right. There we go. And that is it for the Swagger. Yeah, so that's all the metadata that is needed to start our beautiful interface for our API. So now we need to create an actual API. So we say the context. Let's actually make that API /API. You could actually add versioning or overlay functions, so that would be a good thing to do maybe. Versioning in APIs is really hard. So we will have questions, and let's start with a get question, and that will just return a random question. For now, I did not define the schema for our question structure yet. So we will just, as test, return a string, return a result string. We don't have any query parameters. Just do a get and we'll return a random value. So we will just return a random question, right? And the result would be okay, result a random question, right? That way we did not lie. Beautiful, beautiful. So now that we have that, I wonder if it already works. So, or maybe we need to reload API docs. Can't read, right? Yeah, let's reset the namespace. That's not what I expected. So it says that it does not work yet. Maybe we made a boo-boo. Swagger UI spec / swagger JSON. We made a boo-boo, or I made a boo-boo. So reset it. Awesome. Let's reload everything. There we go. Yes, beautiful. So, importance of typing, people. So it says there's a trivia API, which is our title description API for a trivia game. You can be more elaborate here, of course. And it has a question. If we fold that out, and you see the get operation here, get / question, which results in /API / question. And we can test this. That's the beauty of Swagger. We can just test out this method, and it says try it out. If you want to try it out from the command line, it gives you the curl command for it. So if you have a terminal, you could say do a get and it will tell you result random question. The URI that's being used, the response body. So that's beautiful, right? So we are able to see our API, see the description of our API, and actually test it. So let's take the next step and define what a question looks like. So if we do the B part, and a question in our world currently is this, right? So we don't have schema yet. Add require schema core ss. So we can do s def schema, and we will call this a question. And you see that all we need to do is replace our values with the description of what should be in there. In this case, we have an int, or should be long, but let's call it int for now. The question itself is a string, and let's just make our actual, let's take it in 2 steps. Our first part is to replace next question with an HTTP call to our backend service. And if we have that, we have a working chain from front end all the way to backend. So let's do that. Then we end up here saying answers is an array of things. So we actually have a second schema, called answer, which is this. And we can say here that it's actually an answer, an array of answers. So it becomes nicely descriptive. As int, the answer will be a string, and that's a bool. Bool, there we go. So we have a schema, say a question, an answer. And one nice thing with schema itself, you could actually validate or for test cases generate data. So if we go to DB, we grab our first question and say s validate as a question this structure. Seems fine. Validate will give the result. There's also a check, I believe. Explain with validations. I believe it was called check. Validate. Explain. Validate. Where is it? No. We should actually just do this, right? We have a fully working nil, and if we change something, so we did not create one optional key, so everything should be filled. When we remove something, check will tell us not nil, it will say, hey, you're missing ID, it is a required key. So what we created now is a mechanism to actually say, validate should do the same thing. It's a lot more aggressive. It will actually throw an exception saying, hey, you're missing a key. So we have a mechanism to say, I describe what you are going to get. So if we say that the return of this would be a question, and we evaluate it, our Swagger UI will be updated saying you get an object, and this we get totally for free. So ID question, it's fully descriptive. If we try it, it will fail miserably. It will say 500 you have failed live, and that's because we're just returning a random question. So if we go back to our DB and let's create the most beautiful question I found in the list of who wants to be a millionaire, we will return this, right? Try it out. It says, here you have your data structure. Here you have your question and the answers. And this is exactly what our front end needs to actually ask a question. So I guess we're now at the point that we can actually use our API to at least grab a question. So let's give that a try. Even. And this becomes the really nice part that I have no clue how this works. So next question. I know we're calling this at the moment, and what it does, it grabs a question from the database, it increases the round and resets the answer state. And we want this event to fire, but we want to do the HTTP call, right? And as you remember, that's a side effect. And so we should actually change this method to be a co-effects, which does actually nothing really. Let's put this in a comment. In case you don't know, in Clojure you can actually create a structure called a comment, which is quite useful. So the only thing that it should do, reframe, HTTP, HTTP event thingy reframe. Well, let's start with the reframe day 8 stuff here. It's probably one of the repositories, flow, forward effects, HTTP effects. There we go. It's the effects handler that does the Ajax HTTP calls, and it allows you to basically say HTTP XHRIO, the methods, the timeout, the response format, etc. So, what shall we do? What shall we do? What shall we do? There's an Ajax namespace here. Boop, boop, boop. It wraps Google Ajax, so it should. All right. So we need to add this. It's within the Clojure script. Day 8.reframe httpx 0.04. Living on the edge. There we go. Let's add a require that says day 8. I don't know if the Clojure script will really like this. The hot loading of dependencies. The Clojure script part is much less mature. It seems to work. So we have that. Handler with HTTP usage. That's our functions. Do we need to? Yeah, we can. That's obviously a very good thing to do, to have a database have a swirly or something. We're just gonna live on the edge and see what happens. HTTP XHRIO. We have a method called get. Our method type the URI. I wonder if we're gonna end up in course land here. In case you don't know, course is the mechanism that is used to prevent cross-domain activities, and we're not traveling domains, we're on localhost, but we're on different ports, so I wonder if we will run into that, but our browser will tell us. We'll have a timeout. We have very fast serve, so we will just put that 2 seconds. Response format. It has the Ajax, and it says here that it is dependent key. It wraps the Google XRO of ClojureScript Ajax. So that should be included as a dependency already. So that means that we should have Ajax core as something that we can require Ajax. Well, it seems to like it. Did expand do anything funny? No. So let's see what happens. It's beautiful if stuff just works, right? I wish everything did that. Ajax, JSON, response format, nice. And we want keywords. True. I am guessing that will take the JSON object that our API returned, this one. And if you know JSON, you will know that the keys are actually quoted names, And what we want in Clojure is to have those be keywords. So most APIs have some form of changing them to keywords. I'm guessing that's this. And then we need an unsuccess, of course. That's this one. Right. On success. It will probably do another event handler. Question success. And on failure. Question failure. Right? And then yeah, so and then you can just do a regular event handler with a database and have a good HTTP result and a bad HTTP result. So let's see if live works. Event DB, and we called it question success. Success double S. And we call function of DB result, and let's just be wimps and say print DB, print result, of course. And I'm guessing that will be the actual object from the API. So we will be heroes and say current question becomes result. I will be so impressed if this just works in one go, right? And for the failure, we do DB, we print the results, print the result, failure, print the result, we will say request failed result, right? Let's see how life is. So we have failure duplicate key, yes, because that should be on failure, right? On failure. Bruce Howen, the guy who wrote Fig Wheel, magic, right? So what should we expect? What should we expect? If all is well, what we should expect is that the only question that we are getting is this 2002 question, which insect shorted out an early supercomputer inspired the term computer bug. That being the only question, and every time we continue to a next question, we should see a XML HTTP request being passed here. So let's see what happens. Let's clean out logging. There we go. All right. So the first one was not exactly what we expected. I guess we already pre-populated. So the second question will be the XML HTTP request. What we got was yes, course. Everybody's big friend. Course says that the XML HTTP request cannot load localhost 8080. No access control allow origin header is present on the request resource origin. Localhost 3449 is therefore not allowed access. So it's trying to talk to that server, and the server, the web browser protects its user by saying you're doing something that is not described as correct. The security mechanism is called CORS. And so, good luck, but you're not getting anything from me. So how can we fix this, right? One thing that we see here now beautifully is that the on request failure handler kicked in, and the actual data that is returned was this entire part. So that will be quite interesting to see what we get on a success. So, but how do we fix this, right? Luckily, everybody deals with this. So there's a thing called ring course. You should have the main one, right? It's a little bit of middleware. And we did not talk about middleware yet, but you should see it as an event handler, or basically the effects event handler that we already saw. It is code that is being executed before and after a function. So it's used extensively in Clojure. So what we can do now is that, let's do the hide show minor mode. There we go. Have a little bit of oversight. What we want is to include the library that is needed for this. Do you have a version, sir? Oh, here, ring course, right? Ring course. And there's a couple of versions of this. Ring course seems to be this one, 018. Everybody makes their own version. Sometimes it's due to dependencies, but sometimes people just like to add stuff to it, which is really good. Sometimes gets a little bit confusing, so we will add a require that says ring.middleware.course, and we'll add it as course. But where do we put this, right? It says the handler should be rep course my routes, and sadly now we come into some territory that is a little bit harder. So let's define a handler, which in essence is the app being wrapped by handlers, wrap course. And that will be by using the threading macro, we enable using it in different forms with different middleware later on. So we have a app which will be the first argument to wrap course, which should be a function. It will be the first argument, so that's the my routes here. And now we need to add this part that says these options are the ones that we support. So we can say access control allow origin, and we will add 3449, which is the one that was rejected so harshly by our server, and get put post delete. We will remove get and put, and we will only allow get and post, get an answer, post an answer, and then we need to add the handler here. And if I did every handler, right? Yes, I should first evaluate this one, right? And then this one. All right, now it should be the case that this all still works. Try it out. This still works. This is beautiful. And what we should see here is that there's actually some course headers going on, and it still fails. Not allowed here. Maybe we should restart. We evaluated it. We did not. The server is still looking at the app thing, so we need to use our friends the reset function here. It's reloaded. Let's check if the Swagger still works. Swagger still works. Are you still beautiful? Still beautiful. And look at that. Look at that. Look at what just happened. Or are we just very lucky right now? Yes, we had a very lucky moment. We had the same question from our database on the front end as the one that we had on the back end. But what you see now is that our event printed out, here we go, the print result. It actually printed out the question. And it looks like nothing happened. And that is because, if we look at our comment here, just getting the next question is one part of what it should do. If we take this stuff, success, this is where we want to be. We can remove the print. The question is actually the result, so all we need to change in order to do this, add result here, associate. So now we moved the code that we originally had in the next question handler. We moved it to the question success. The result, which actually is the question, is now being added to the database structure as current question. We left the rest intact. Let's clean up the comment that we created here. So yes, beautiful. So question success. No, I did this all wrong. Sorry. No, I did it right. I did it right. Be gone, spawn of darkness. I did it right. I did it right. I thought I accidentally changed a different handler. There you go. All right. So we used to have all this code, or actually this code. We used to have it as part of our next question handler. So now the next question will be kicked off, and it will actually do the HTTP request to a method to a known URI. And this is obviously bad design, right? It's hard-coded a URL. We need to figure out a way to have a configurable URL here. But for now it works. It has a max time of 2 seconds. And when it's successful, it calls the question success. And when it does that, we take the result and we reset the game to the next round. So we should be happy here, blah, 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 bam. 100 billion, yes. The next question should come in and we have our question from the database. We have achieved success. So we see a flaw in what we're doing. The create game is actually already using this, is already having a question passed into it without it coming from our backend, which is not very good. We need to fix that later on, but for now, let's say that we leave all this, we take all this from there, we leave one question in this database, so that will always be the same question being asked. We need to change this mechanism, but for now, awesome it is. And the next question will now always be this one. So what we need to do now is create something that has a database of questions, right? If you remember, we have the handler here. If you remember, this is just a component, and it can depend on other things, right? So it can depend on a database, perhaps. So, and then when a API is called, perhaps we can just return a question from that database. So then the question becomes, how do we pass along a component's dependency to the API itself, right? Let's first create our database. Let's do that. In memory db.closure. Yeah, and def db becomes, there we go. So we created a database, which in actuality is just a list of questions. So we created that, we're fine. So let's create a record that says in memory db. It has no dependencies or anything, but it implements components life cycle. We add the stubs for it. This is so much Java-like, right? I like that. It's just components. And as we have absolutely nothing to do here, we can leave it at this, right? The database here holds the values. Oh, it's a snippet expansion. It holds the values. It's our database. So maybe we should do a def protocol for databases, saying protocol that holds DB actions. It would be a protocol for which all the future implementations of a database that should adhere to, and we will do get random question. And now we can say db is a, cannot find it, of course. Oh, there we go. Look at me being not so useful right now. Definition of function get random in protocol db must take at least one argument, and which is this, right? Because it's a record. This is fine right now. So now we add a function to our record that says get random question. So any future database implementation, and does not make a lot of sense to put it in a in-memory database itself. So we should create a DB protocol. There we go. All right. So DB actions. Why not? So what it does, we created a DB protocol namespace that has a protocol to deal with database actions. And in this case, we have one action called a get random question, which should be implemented by everything that is a database. Let's add the privia.db protocol, db protocol DB actions, and now we have this, and we can get a random question from a database. And if you remember, we can just do, in this case, rand and DB, and it will we did not evaluate this yet. And it will give us a random value from that database. So we created a random access to a data store that we can use. And in our system, we can say we have a database. It's called trivia.in-memory database. And we did not create our new database yet. New in memory DB, no values, and it's a map. I did not evaluate this one yet. There we go. In memory database. Zero. One. Yes, there we go. Has access to that one. Then we say here in memory database new. We should evaluate it. Daniel Schiffman has this dot song, right? I should have a let's evaluate it song. There we go. We can add config options. There's no options to pass on. And now we can just say within the HTTP, this is a component that is actually using, if you remember correctly, DB. And then in the web server, we can tell the component that it should actually pass the database. So now the database becomes available to this entire life cycle. And we know this database actually implements something. So now we need to make this database available to this API. And that is quite interesting. So what this does, this dev app, it returns an API, and an API is nothing more than a compojure-api route. So maybe we can create a closure, a reference, if you will, from here to hold the database. And so when this is called, let's add the namespace trivia.db protocol. We can call DB protocol on the actual database. Let's give that a try, and let's say then we can change handler, yes, definitely handler, to be a function which has a database reference. I don't know, I'm not very sure about this, so let's try it first, right? And the app, we can get rid of this then. And the app, it should actually, so let's clean this up a little bit. The app should actually be calling DB protocol get random question on the database that we have, right? So instead of being a definition of an app, we can have a function that returns it. And the function will have a reference to the database, and that it will be wrapped. Right. All right. Okay. This might be a horrible idea, but let's see if it works, right? So we have a web server, and that starts to run, and it will. I wonder if I can then do this, right? Oh, that was not very good. Good. Be normal. Why did it do that? All right. Maybe we can use it as predicate, so it's executed every time. All right. So within the web server record, we will be getting. Typing. Damn it. We will be getting the database as a dependency to our component instantiation, if everything went correctly. And then from the lifecycle, when it starts, we create a handler that has a database reference. This handler will call the app to create an API, which is also passed the database reference. And then that database reference is used in the result of the API call to actually call the protocol get random question on that database. And as it is in memory, let's see what it does, right? The worst thing it can do is fail miserably. Let's make sure that everything is evaluated. System, this is also quite new. It's also working. So let's do a reset. Oh, and it failed miserably. Let's see what went wrong. RT, wrong number of arguments passed to new in-memory DB. New in-memory DB is right here, and in-memory DB, okay, config options, that's just my bad. There's no keys in there that are relevant because the record does not do anything with it, and we're not doing anything with it as well. Yes, so that should be better. Right, that should be better. And now reset will fail probably. Yeah, reset is not available in this context. What happened is it failed during the reset, so it cleaned out the entire namespace and then failed miserably. So the core namespace is not known at the moment. It does not have anything. And we are in, I think, a bad situation at the moment. Wrong number of arguments, one passed to a web server function. We did something really bad. And I'm thinking it is this part here. This part. Let's give this a try. Reset. Oh, that did something. Give it a try. I think. Wow, it works. It works. Yes, I think we also made it that we have a full failure in the case of a change, but I'm wondering if this setup still works. Nah, it's not a reference. Yeah. So now when we have changes to the API, we will need to do the reset because this is evaluated, has a value, and it is not referenced every single time. So we need to think about that. But what it should mean is that we now have an interface that first asks how cool is it, and then every single question that follows, Igor Sikorsky, right? Amsterdam, every single question you see here below, 93 million, is taken from our backend corner. Oh, which one was it? So 4 to 1. So it knows it's correct now because it retrieves the answer, the question from database with the full structure of the answer, which says it's either correct or incorrect. And we can see that here, I believe. Question and a response. And here you see the response, the answers. My head is probably in the way here. Okay. So you see the answer here, and it says answer correct, false, right? So we did the first part, the get. It's already 11:29, so we've been at it for an hour and a half. So what we achieved is quite remarkable already. We created a web server. We added a HTTP component. We added a database component. We added a protocol that says how to talk to this database component. We have the database as a dependency on for the web server. What that means is that when we are ready for it, we can just say, instead of using an in-memory database, use a MySQL or a Postgres database. So that's quite something that we achieved already. I'm gonna call it quits for now. It's been quits. I really feel like we should actually do the post still. So it's 11:30. Let's just throw away the hour and a half limit, because I would really like to say do the post. There we go. I would like to have a post to question ID. So what I would like to see is that we do API/question/12345. Oh, yes. Tries to evaluate it. It's not very useful. 1, 2, 3, 4, 5. It's evaluating. It's trying to figure out what I'm trying to do, right? Have this post. Hello? Oh, no. Have this post here. And then post to this question, the answer ID being 2, right? And then in our database, we will look up the question, look at the answer, and return true or false based on the correctness of the answer, right? Let's not change anything to the API yet, in that we change the way the answer is returned or the question is returned, and we'll leave that for next week. But I would really like to have the change here. So we'll have a path params. Would it be ID int? I don't know if that's correct, right? We'll have and a return would be a dummy. There we go. That was a colon, right? Colon path params long, and this would be a bool, and then summary returns true or false for the answer, and let's test it by saying okay, true. And that should mean that we now have just to get, right? Because we need to do the reset. Oh, and I did something really bad again. It's gonna bite me in the ass, right? Pattern. Closure keyword cannot be cast to closure line I object. 31. And if you remember, core is now not. We will evaluate it, and it says review web server not found. The entire namespacing is now kind of messed up, and it still says bool not found in this context. Boolean then? Is that correct? Yeah. Save, yes. Now go to system. System is now also, oh, scratch. System is now also no longer namespaced and now core. Right, and now we can do a reset. Okay. Question now has the post as well. The post, we can say ID 1234, and bam, it will tell us 404. 404. Why does it tell us 404? That's not something I expected. Web server. No content. I did not expect a 404, but that could be because REPL. I did something dumb with it knows the path, right? It knows the path, knows the ID part. So maybe there should be something in the there should be some documentation. Check the wiki for links, routing, path, params, get name. Documents. No, I just want path params, man. Let's see. Component integration. Oh, there's a entire thing about component integration. Did we do it correctly? DB. Ah, look, we did it correctly. I think. Injecting components via the request. I will take a look at it. Maybe there's some better way to deal with it the way I did it. As we are not littering the request. Yeah, so we used closures. We did it something really good. But how does the path params work? There should be no asint. Server. Asint, return a boolean. I think something else is quite wrong. what? True. So 404. Just path is int. Well, we told it was a. Let's try restarting the REPLs. Let's see if that. If all else fails, try turning. Have tried turning off and on again. That's what I want to say. I wonder what the reason for this is. Maybe it doesn't like it because the get post. Nah, it should. Thinking maybe it doesn't like this part, the get on the URL and then the post, but that should be fine, right? It's quite interesting. Debug. Can also do the serving of static resources, which I will add later, to actually load JavaScript, so we can add it to, for instance, Heroku, and so that's not running at the moment, which is exactly what we expect. We call core. It says 4. I'm wondering if I just do the curl. I've had this before, that one thing thinks it is running, the other does not. Never really figured it out. See? I think there's something wrong with Swagger in this case, which kind of makes this pointless to do, right? True. Yes, and then we'll do the reset. There we go. True. Alright, so just using the curl to call the API works, but this one does not. Maybe there's. So this one thinks that it does not exist, right? That is really odd. That is really odd. And it does do the request URL API. For some reason it is getting, I don't see any origins as well. So I guess the Swagger thing is quite useless at this point. Yay for figuring that out. Let's see if let's go back into our database protocol, and then is answer correct? Oh. Correct answer. This question ID answer ID. And now we need to implement in our in-memory database. First we need to evaluate it. There we go. And then random question is already. There we go. Question ID question ID answer ID. And then if we go back to our event handler, submit. We had this really cool piece of logic that said, there we go, filter out, if we have a question, filter out the answers and then look if the answer ID is the same, and then return that answer ID. And based on that answer, we can say, is it correct or not, right? So for this to work, we first need to get the question using exactly the same logic, really. Getting the question is the answer. So from the database, question ID, it's actually better with a dash. Reads better, right? From database, iterate, look at the IDs, find the one that is actually matching question ID, and then from that, grab the answer that is matching the answer ID, and then based on that, we will say, and then it will return true or false, and we say correct answer. Yes. So if we look at this, it will first, if we do 1, 2, 3, 5, it will grab this, then it will go through this list and say, well, I'm looking for answer 4, and then it will, in the end, return correct, which in this case is true. Seriously, there we go. So it's a little bit fast for the normal tempo, but what did we do? We added a function to the protocol that says, hey database, is this answer correct? Given the question and the answer ID. We looked up the question, we looked up the answer, and then we returned the true or false value from answer. There's something very interesting. Suppose this returns nil. What will the result be, right? Would it be nil or an error, right? It's a list, right? It will be nil. So answer will be nil. So, and then correct on nil will be nil, which is not true or false, which will make the API fail. So let's ensure that our API always returns true or false. If nil answer, then false, and else return the actual answer. That way we are not faced with errors. There should be some more intelligent handling of this error, but it should be fine for now. And now we need the API to call this. We already did that, which is right here, and now it currently says true. We only have a post to the question, and the post should actually have some value as well, right? API middleware, we're not interested in that. We need the post. Post-mortem. No, just go here. It's probably called body. Body is answer ID, and it will be an integer, right? Let's see if this works. See, and then we can say DB protocol correct answer for the question ID and the answer ID. seems that it would be this, if I think about it. The variable and the type. So, no single method correct answer, question mark of interface. Found for functions correct answer of protocol DB actions. Did I forget to evaluate? Correct answer. No, what I forgot to do was to say do it on this database. You're basically saying on the object DB, call this method with these parameters, right? So it's back and forth. So it tried to find the correct answer on the, in this case, an integer, which will fail miserably. And I think we're back. No, we're still going strong. The Swagger part, I need to figure out why that fails. But we can use the Swagger part. Maybe the Swagger part didn't like it that had a no content 404. It's horrible. I don't know why this fails. I will need to figure that out and maybe talk to the community. So what did we say? We did a post to question 1235 and we said body being 1 and what the answer should be. Let's see what the answer should be for 1235. Database, in-memory database, 1235, probably 4, right? 4. Returns true, and anything else returns 3, 2, returns false. So it works. So now what we should do is go into our events. We have submit answer, and for now with submit answer we grab the question, grab the answer, see if it's correct, but all this is actually the dealing of with the answer from the API. So let's move this into a comment real quick, and we are basically doing the same thing we did here. We do a XML HTTP. We should grab the entire thing, right? The entire cofacts pass along. The only thing that we do is saying submit answer. Answer success and answer failure, but we do a post to event, and when we do a submit answer, if we submit answer, the event that was like this, right? The event question ID answer ID is basically all that we want as well, so we can reuse that entire thing, and we can say we'll do a very nasty thing saying string combine question ID. Would it be body then? Body. Well, why not answer ID? We will post, and it will have a form of either success or fail. And when we have a success or fail, we should dispatch around. We will update the answer state, so the UI will change, and then we basically can do this entire thing what we have here. Reframe, register, event, effects, answer success, and we will have this this entire thing, but for now, now it will not have the question ID and the answer ID as parameters. It will have a result. Are we interested in DB? Well, we're not interested in question. We're not interested in answer. We have the correctness is already, the result is the correctness. So this should be just result. And that reminds me that the response format is not JSON, right? Reframe. C, optional C API docs. All right. Where are the API docs? No API docs. Let's see what the code says. Response. What's it called? Response format, right? And we call this the event handler. When it's invalid, to do map requests XRH options on success. That's request associate handler, blah blah blah. Right, last method, which is then probably in this library. It's a wrapper for this, right? And then response format specifies that you'd like to receive certain format. If not provided, a permissive accept header will be sent and the response body will be interpreted according to the content type. We'll just wing it, right? So we have a result that's either true or false. Maybe we can just do the correct, incorrect. Result, state, answer state, this is all state, the DB. So we update the database when it's successful, and we do a dispatch. So let's assume for a little while that in case it fails miserably, we will just do nothing. Our game will freeze and nothing will happen. We probably can create a general failure handler here. But if we did it right, what will happen now is when we do a submit, there will be a submit XHR request to the backend, and it will tell us true or false based on what we did. I'm very curious if this works. We log in, we do next. Unrecognized response. Know what we'll do? Web server. Let's create a quick schema that says def schema question answer correct will be a boom. So what this will do is that we will have a schema that says, instead of having an answer, we can use the answer becomes a question answer. And the protocol will be this, right? Protocol we will have correct as a answer ID, right? No, Arjen. Answer ID. This is still an int, and the return will be a question answer. Answer to a question. All right, enough messing around. Okay, let's see what Swagger says. Swagger says we'll return a boolean because we need to do a reset. And reset says, well, do it yourself, right? And that means unable to resolve answer ID in context. Where did I miss it? 38, it's right here. Answer ID. So why are you messing with me? Lies. Reset. Core. Rebel. Lies, right? So now it will tell me correct, true, right? So if we go to the event, when there is an answer success, we'll have a result, and we can change it back to correct result. We'll grab the key here, and then the format here, submit answer is already keyworded, that's very good. And then where it says correct, it says this, correct. All right, wondering if this works. Request failed, answer not integer nil. Bad request 400. Not integer nil. So the body is probably not correct, right? Request failed. And can we see the request itself? Headers preview. It's form data tree. View source tree. So the form data has tree, so it has data. It has data, right? Maybe let me say let's look at the documentation. Always a good thing. Post formats, JSON request formats. Post URL request format, send message. Ajax. Let's see if that works. Guess it gets tricked by the, that's 400. bad requests. Content type, application form URL encoded. Let's see what the content type for the post here is. Application JSON, right? So what we should do is say hello world, it is JSON. JSON request. All right, we're getting somewhere. It's a long and arduous road to getting it correct. It's Ajax. That's why it failed. Didn't see the. Still shows. No, it says. Still says the request. Did I just bite off too much that I cannot chew? Let's see. Let's see what happens if I do answer ID this. Answer ID 3, and it still says not integer nil. Nil. Why does it think it's nil, right? Let's see if it still works if we do the 1, 2, 3, 5, 2. This fails for some reason, right? But it throws us this. This works. Maybe there's a data params. Handler, params. Maybe it's instead of body, it should just be params, right? Params sounds to me that they expect a key value pair. Well, that was interesting. Did you see that? What city is in Amsterdam? It is correct. So we do a get to this. We have a post for no properties and a response. True. All right. So the only problem was that I had body, which was a pure guess. Where is he from? Peru. San Francisco will be red. Iceland. Red. Yes. We did it! Hey! Woo! So yes, what we did, we have a post to a question ID, which works perfectly. The Swagger UI, it fails miserably on the post. I do not know why. I will look into that. And from our events, we submit the answer, which is just an XML HTTP request. It does that to the URL. It will retrieve a state. That state will be used to determine if the question was answered correctly and update the interface. So we now have a fully functional application talking to the backend, which is quite awesome, and it only took us 2 hours and 10 minutes to do, right? Well, at least we did it. We set out to, we achieved what we set out to do, which is great. I'm gonna sign off now. If you liked it, press the thumbs up. If you have not done so already, subscribe to the channel. There is a very nice Yeah, we have another subscriber. Welcome. There is a nice, if we go back here, discussions board here where you can add comments. Be sure to add some comments. It is very nice to talk to everybody. Well, let's see. Next week, Friday, 10 a.m. Central European Time, we will add more features to the application. I will round out the interaction, make sure the entire application is running through the backend. In the meantime, I will probably add some Docker stuff to it. I will post about it on buildfunthings.com as I did previously on the Docker. Loading more. Just getting it to run in Docker. I will add maybe a Heroku instance to it. I will see. Be sure to check it out. It will be quite awesome next week again. So let's sign out. Now I always forget where my live coding thing is, right? There it is, the control room. I will stop the stream. Have a good day and see you next week.